The AVA toolset consists of 6 primary tools, each playing a distinct role in the puzzle-solving pipeline. Set a puzzle. This tool kicks off the process by initializing the puzzle and generating the necessary embedding vectors for the words. Get embed recommendation and get LLM recommendation. These tools provide automatic group recommendations using embeddings or direct language model insights, respectively. Get manual recommendation. For cases where manual input is required, this tool lets users suggest their own word groupings. Apply recommendation. This tool applies chosen recommendations, updating the puzzle state and guiding the next steps. One-way analyzer. Finally, this tool handles the error condition where 3 of the 4 words in a suggested group is correct. In the following slides, we'll dive deeper into each of these tools to explain their functionality. The Setup Puzzle tool is responsible for initializing and configuring the puzzle environment. At a high level, the tool sets up the initial state by initializing AVA's memory component, the puzzle state class attributes, generates vocabulary and embeddings for words in the puzzle, creates embeddings for word definitions, connects to a database, creating the necessary table and storing the vocabulary and embeddings for the puzzle solving process. Ultimately, the tool returns the updated puzzle state, ready to start solving the connections puzzle. One step in the Setup Puzzle tool process creates the word-related embedding vectors. It does this by generating diverse definitions for words, providing multiple connotations across different parts of speech. Let's break down the process step by step. On the left side, you can see the prompt we use to instruct the LLM on how to create word definitions. It instructs the model to generate as many varied definitions as possible for a given word. The process works like this. Identify parts of speech. The model lists all potential parts of speech the word can take, such as noun, verb, or adjective. Generate definitions. For each part of speech, it produces multiple definitions. Each definition is annotated with the parts of speech. Compile and return. Finally, all the definitions are combined into a JSON object that organizes them into a list format. Here's a quick example. If the word is run, the JSON response might include entries like noun, a quick sprint, verb, to move quickly on foot, adjective, related to being operational. Now let's move to the right side of the slide. Once we have this collection of definitions, we perform the next step by using OpenAI's Text Embedding 3 small model. This model converts each definition into a 1536 dimensional vector, providing a numerical representation that captures the meaning and context. You can see sample output in the data frame below. For each word, there's a list of definitions, and for each definition, the corresponding embedding vector is generated. This allows us to perform semantic clustering to find possible groups of 4 words that have a common connection. The Get Embed Recommendation tool is designed to make word group recommendations using embedding vectors described in the prior slide. It does this by retrieves word embeddings and definitions from an external SQLite database, generates a list of potential word recommendations based on embeddings, ensures quality by using a large language model to validate the top candidates, incorporates the validated recommendations into the puzzle state. The tool ultimately returns an updated puzzle state with a word group recommendation. Get Embed Recommendation tool generates word group recommendations based on cosine similarity of the embeddings. It accomplishes this with the function getCandidateWords. This function identifies and groups similar words by analyzing how closely their embeddings align through these steps. First, it generates a pairwise cosine similarity matrix for all word definitions. It sorts the cosine similarity matrix to identify high matching word definition pairs. The function identifies the closest matches for each word definition. From these, candidate word groups are formed and ranked by a group metric that measures their overall similarity. Duplicate groups are removed to ensure the results are unique and sorted by relevance. A final list of candidate word groups are returned that are used as the basis for recommending a 4-word group. This slide introduces the Get LLM recommendation tool, which utilizes a language model to provide intelligent word recommendations. The tool is designed to automate word selection and grouping. The tool updates the system to reflect that the LM recommender is active. A structured prompt is generated, incorporating and scrambling available words to ensure unbiased selection. The tool engages in a loop requesting recommendations from the LLM until a valid result is obtained or retries are exhausted. The system evaluates LLM responses, storing successful recommendations and updating the puzzle state. If unsuccessful, it switches to manual input. The end goal is to provide an updated puzzle state with meaningful word recommendations. The Get Manual Recommendation tool is designed to give users the ability to manually suggest word groupings and define their connections. It enhances flexibility by allowing user input, which can be useful when automated systems are not producing the desired results. When activated, the tool shifts the system to a manual mode. Users can propose groups of 4 words, validate their choices, and define connections. The tool ensures that the recommendations are derived from available words and integrates the user's input into the puzzle state. By updating the system with manual recommendation, this tool empowers users to guide the process more directly and ensures more accurate or creative solutions. The Apply Recommendation tool processes the connection puzzle's responses to word recommendations and adjusts the puzzle state based on whether the response is correct or not. The tool works as follows. It counts recommendations and retrieves responses from the connection puzzles entered by the user. If the connection puzzles indicates a correct word group, the state is updated and progress is recorded. If the connection puzzle indicates an incorrect word group, mistakes are tracked and adjustments are made to guide future recommendations. The puzzle ends when all words are used or the mistake limit is reached. Based on the outcome, the tool adapts by continuing recommendations, switching strategies, or prompting manual input. The tool ensures smooth progression by dynamically managing the puzzle state. The one-way analyzer is a specialized tool for handling one-way errors. The purpose of this tool is to analyze groups of 4 words and where the connection puzzle indicates 3 out of the 4 words belong to the same category or topic. The tool works to find the correct 4th word that would complete the set. The process begins by generating a combination of 3 words from the set of 4. The 3 words are called anchor words. Since there are 4 words in total, we can form 4 different combinations by excluding 1 word at a time. Each of these combinations of the 3 anchor words is sent to an LLM to determine if they form a cohesive single topic group. Next, the tool gathers the responses from the LLM. It filters and identifies combinations that form single topic groups. If multiple valid groups are found, the tool randomly selects one. If only one valid group exists, that one is chosen automatically. Once a valid group of 3 words is selected, the tool generates a new prompt for the LLM to identify the missing 4th word that would complete the set. The result is a new recommended group that includes the selected words along with an explanation for their connection. The output of this process is either a new corrected group of 4 words if a valid match is found, or the result is none if no valid topic group can be formed. This tool enhances accuracy by leveraging LLMs to detect subtle misalignment in word groupings. The table on this slide identifies the key files that make up AVA. app-embed-vec.py. This is the main entry point for the application. It handles command line arguments, sets up logging, reads configuration files, and runs the entire workflow. Essentially, this file initiates the application and manages the overall response functions. PuzzleSolver.py. This module is critical for solving puzzles. It contains the core logic for setting up the puzzle, generating recommendations, and applying those recommendations. Additionally, it defines the state of the puzzle and includes helper functions that interact with large language models, generating vocabulary and embeddings. Tools.py. Moving to the next module, Tools.py, this file provides utility functions that enhance user interaction. It handles tasks like extracting words from images and communicating with the language model, making it a vital support module. Workflow Manager.py. This file manages the workflow by selecting the appropriate tool based on the current state. It continues to run the workflow until completion, ensuring a smooth and efficient process from start to finish. EmbedVec Workflow Specification.markdown. Finally, this markdown file serves as instructions for the planner. It provides detailed instructions and includes a decision table that outlines when and how each tool should be used. It also specifies actions to take when certain statuses are encountered. This drives the workflow process. Together, these modules power the Agentic Virtual Assistant, Ava. This concludes the overview of Ava's design and implementation. Next, and the last topic in this video series are the lessons learned while developing Ava. Things that worked well and, just as importantly, the things that didn't. For those of you interested in deeper dive, all the code and resources can be found at the GitHub link shown on this slide. If you found this content of interest, please like the video and subscribe to the channel. Thank you.